Hi, London. Welcome. My name is Ian Cooper, and hopefully, thank you very much for coming at 17:40 to hear me speak. This is with kind of the group of death. There's a load of really good speakers on, so I'm also grateful I'm not talking to an empty room. It's been, I think it was last year, was the 10th anniversary of James Lewis and Martin Fowler producing their paper on microservices, which really, in a typical way of, say, ThoughtWorks, captured what they saw as being a new emergent movement in software architecture, influenced by things like fine-grained SOA at Netflix. And they captured it all in a paper, and it had impacts on the industry. For a while, it was very popular. Everyone was like, I want to be doing microservices, right? And of late, what's happened is a bit of a backlash. People are all like, you know, microservices are terrible. Let's all go back to the monolith. So this talk is a little bit about, in much the same pitch of anyone who's seen my TDD, Where Did It All Go Wrong talk. It's a love letter to microservices, and it tries to explain where I think people have been going wrong with microservices and why they hate them, and when they should actually use monoliths, but how you can kind of fix your journey into microservices to use them better if you want to. I'm old. That's really what that slide says. Okay. I work basically on an open source project for .NET. Any .NET devs in the room? Yeah, we compete with mass transit. It's called Brighter. Where's Toby? Wave your hand. Toby, I tell you what, I got some stickers somewhere. I got like the few left. They give them to Toby. Mind your head, don't want to kill anybody. I'm a terrible throw. Toby's a better catch than I'm a throw. So Toby can hand some of those out for you if you want a laptop sticker from us. It's weird alternative to say mass transit or service bus. We've been around longer than either of them in the role of a framework. Both of them started as brokers for MSMQ, and we were a framework, and they pivoted to become a framework later on when they dropped being a broker. So we were actually first. We also can be used in a CQRS role, and we predate Mediator. Jimmy copied most of our stuff because he wanted to use it but didn't want all the messaging framework. All right. So I'm going to start off, we'll have a little talk about some fundamentals and definitions, because I think one of the things we're going to need to do is agree some terms so that we can then talk about what microservices are. Then I'm going to focus on what I think are the key misunderstandings that have led to the problems we find ourselves in with our microservice practice. And then I will try and give you some pragmatic advice about the way to view the world that will help you use monoliths or microservices as appropriate on your journey to doing software. Laughably, I put Q&A at the end. We're never going to have time for Q&A, but it's kind of that thing you do at the end. There'll be time for questions, right? If I finish with about 1 minute, we'll be lucky. All right. So some fundamentals and definitions. Let's agree the meaning of some words and some ideas. So as I'm sure you know, since 1973, there has been a well-defined fundamental theorem of software engineering. It is late in the day, so I'm going to forgive you if it slipped some of your mind. I could pick on Toby and say, Toby, can you remember what it is? But that's really unkind because it's late for Toby too. But that is the fundamental theory of software engineering, as I'm sure you all remember. With that done, I think we can move on. Okay, I will explain the fundamental theorem of software engineering. The fundamental theory of software engineering comes from Edward Yourdon and Larry Constantine. It was defined in structured design in about 1975, but probably predates that. It may well really go back as far as the NATO Software Conference in 1968. The NATO Software Conference, those you don't know, was designed to answer the question, how do we get faster at doing software development? A question we have been asking for the last nearly 60 years, right? Due to complexity, it is always easier and cheaper to create two small pieces rather than one big piece if the two small pieces do the same job as the single piece. This is because combining two problems in one piece forces us to deal with the unneeded interactions between the two pieces. Right, let's reason about that. So I currently work at Just Eat Takeaway. We deliver food to you. If you can imagine that if I had a piece of code and I said, you know what, I'm going to put in that piece of code a pricing engine for your basket and courier assignment, you might go, do those things really live together, Ian? Are you sure? You sure that makes sense to have those all in one code base? And are you sure it makes sense to have all the code for this running into the code to that? You probably go, it's going to be a lot easier if we could break that up, right? And that's all that's really saying. If I have two different ideas, or three ideas, or four ideas, or five ideas, we can all rationally agree it's probably going to be easier to break those pieces up, because then we don't got unwanted interdependencies between those items, right? And we can rephrase that as follows. The cost of a computer system will be minimized when the parts of the problem are solvable separately, right, and manageably small. That is how we reduce the cost of software. There was a note even in 1975, everyone has a different definition of manageably small. And that lays the crux of much of our pain, right? But the idea is breaking software into parts helps us manage it. So how do we break it into parts? So modules are this key idea that emerged back in structured programming in the 70s. And Jordan and Constantine defined it as follows. A lexically contiguous sequence of program statements, in other words, kind of like a script that goes from one end to the other, bounded by boundary elements. So in other words, it's in some kind of box, so in .NET an assembly, or in Python a module, having an aggregate identifier. It's got a name. Another way of saying this is a module is a bounded contiguous group of statements, has a single name by which it can be referred to as a unit. So in other words, we can break our software into pieces, we give it a name, and we contain some amount of code in that space. Okay. Martin Fowler defines a software component as something that is independently replaceable and upgradable. In other words, I can swap it out either to upgrade it or to replace it, and the other things that make up my system won't care. It's a component, plugs and plays, right? Two main types of components we tend to use. Libraries. I would include frameworks and libraries. So something I run in process in my code that I leverage to go faster through reuse. And services. Something I talk to in another process. We'll come to that in a second. Okay. Components are modules, but they add the characteristic that they are replaceable. In other words, I can swap one for the other. So if you have essentially a module that has a well-defined interface where you can swap in another thing that has the same interface, either because it's an upgrade or a replacement, then effectively it's a component. You can swap one for the other. All right. Pretty straightforward stuff. Okay. A service. So a service is a component that exists in its own process. Clients talk to it over some inter-process communication mechanism such as RPC, RESTful calls over HTTP, or messaging, right? So a service is a component. If it's a component, then effectively it's an independently replaceable or upgradable module. A module is just a named collection of some code, all right? So for services to be components, the upgrade or replacement of one service should not require coordination with another. Seems straightforward. That's how we build software. We've been doing this since the 70s. That's kind of all of the structured decomposition model, basically, that we have. So microservices are just a set of practices for successfully building a software component architectural style at scale. So in other words, we're going to use those ideas at scale to break up our software. All right, so this definition comes from James Lewis and Martin Fowler. Componentization via services. In other words, we're going to use components, independently replaceable units, and we're going to use services. We're going to put them in processes, right? And in that note at the bottom, often you will hear this phrase used, the phrase independent deployability. What that means is if I want to upgrade one component in my architecture, I shouldn't have to impact anything else, right? I should better replace or upgrade a single component without taking down all my components. If you find yourself in a world with your microservices, where in order to replace one of your microservices, you need to take all the others down, then it's not a microservice, right? You haven't met the service definition, which hasn't met the component definition, which is independently replaceable or upgradable. Typically, that's why you tend to use things like messaging, because it makes that a lot easier, right? organized around business capabilities. So effectively, when we do that breaking up, we're going to break up according to elements of our business's domain model. Smart endpoints and dumb pipes. In other words, the domain model should live in our services, not on the communication between our services. And we should design for failure. So as well as being replaceable and upgradable, it would be good if one of our components could fail and we would survive that, either because we have some kind of scaling out, so in other words, the failure of one doesn't really matter, or because we use something like messaging, and therefore effectively we have a bulkhead to failure because work just queues waiting for the component to be restored. Messaging will also help with independent deployability. That gets us towards reactive architectures, and that's not really the topic of this talk. We will need, in addition to support these design ideas, infrastructure automation, because if we're going to have a lot of independently deployable services, that's going to be too much to do it by hand, right? So we're going to need to basically be able to deploy by infrastructure automation. We're going to want decentralized data management. If every service, right, is this independent unit, then it and it alone owns its implementation details, including its data schemas and the data living inside it. So in order to basically manage, I want to view, I don't know, our sales figures for the last 3 months, I'm going to have some way of getting data out of those services and collating it together centrally, all right, by exposing it via events or the like. Decentralized governance, right? In other words, we're not going to be able to work in a model where effectively you have multiple teams who are all supposed to be working independently on their services if everything has to go through some kind of change control board. We're just going to really end the value of that. So we want decentralized governance. We want to give teams quite a lot of independence to be able to release and deploy their software on their own, right? And we think about products, not projects. In other words, we want product managers focused on a given microservice and taking that forward rather than thinking about projects that include a whole load of them, right? That's the basic definition of microservices. But as you can see, the key idea here, right, it's a replaceable and upgradable unit of code that is aligned to a domain that essentially achieves isolation through the process model. Benefits, strong module boundaries. Process boundaries are strong. They're hard to cross. It's not like basically changing, you know, the boundary between two classes in your code. It's a lot harder to change. And that's good because effectively it means you won't reach in to the implementation details on the far side. It has negative consequences too. Independent deployment, right? We've said that effectively one component cannot affect the other in terms of its replace or upgrade. So essentially that's a benefit. We end up being able to independently deploy any component. Teams gain control of their own release schedule. Technology diversity, each component can effectively run its own particular language or frameworks. And fault tolerant, right? If we're essentially going to build these things to survive failure by scaling out, by using message queues, then essentially our overall architecture will be resilient to the failure of an individual component. And cognitive load is reduced, right? Microservices have a principle of code that lives in my head. And that's actually what the micro refers to, right? And technically, it's code that lives in James Lewis's head, according to the definition. But James has got a reasonable sized head, so it's probably a reasonable sized amount of code. Costs, distribution. Distribution is always a complexity multiplier, right? We start dealing with networks. We start dealing with issues of, you know, is the network up? How much bandwidth, latency, etc. So that's going to cause pain for us, right? Verification. It's kind of gets a bit harder to live in a world where effectively you say, oh, what you should do is just test the API of your microservice and then deploy it. And provided the contract's right, it'll all work. And everyone's a bit like, really? I'm not sure I entirely believe in that. And people want to test end to end. Can I deploy everything onto my computer? I'd really like to deploy the entire application and all of the microservices, right? Operational complexity. Essentially, every microservice is now going to have need telemetry, deployment scripts. The cost of effectively operating all of these services goes up, right? It's bad enough that usually we have one person on the team that will deal with the build scripts, but you multiply that problem now by about, you know, X number of teams, and you've got X number of people that need to deal with the build scripts. And skill issues. right? We may well have now be dealing with lots of things that people are not used to. We may want them to do messaging, and they may have only ever done HTTP, all right? So we may have a whole range of upskilling to do to get the microservices. And data, right? How do we get hold of our data now? It's all distributed everywhere. How do we, we want to build everything with new Gen AI products. How do I get hold of my data now? It's all in all these microservices. This seems like a bad idea. Well, it was just in one big database. That was easy, right? Okay. So we think of these problems as the microservice premium. Right? Ages ago, right at the beginning of microservices, I gave a talk about microservices, right, really early on. It was at NDC Oslo, and a friend of Toby of mine, Liam, was in the audience. And I got to some point, basically, the audience was really enjoying what I was saying. I got to this point saying, yeah, unless you're about 30, 40 devs, you're not going to need microservices. And he said, half the room turned against me. He said, because they brought their boss to explain, we should be doing microservices, boss, our team of 5, right? And they went, I was no longer their friend. But the problems you're trying to solve are as follows. The code doesn't fit in your head, right? I have this really large problem and I need to break it up into pieces. So that tends to lead you towards some kind of modularization or componentization. That itself doesn't mean you need microservices because you have a modular monolith. A 5-pizza team. So this pizza team idea, a pizza team is about 6 people. It's just rough, right? So this is really about 30 to 40 people. Once you get beyond about 30 to 40 people, it's difficult for us to communicate properly about what we're doing. And, that smaller number, we can all fit in a room, we can all shout at each other, call each other, question each other's parentage, that kind of thing. But when we get to bigger than that, we're probably in separate rooms, maybe in separate buildings, and that gets harder. Okay. Toby and I once got told off. It turns out that Gen X are much better at calling each other names and being friends afterwards. And the millennials all complained that we were creating a toxic workplace. Subdomains have different forces for change. So if you have things that essentially create separate forces for change, if they're all co-located together in one space, that becomes very difficult because, everybody wants to be working here in order to try and resolve their particular requirements, and you're all getting in each other's way. So if you can try and break it up to move everybody into different places, you'll go faster. And a wide range of interaction styles. So typically this is I need web, I need mobile, I need to talk text to Gen AI, whatever it is effectively that you're doing, all right? The more interaction connections you get, the more likely you might to break up into microservices. Sometimes it's just summarized as this, all right? Like one of those fairground rides, be tall. All right, so where did it all go wrong, right? Where did we get into a world where people's microservices efforts ran into significant problems? The problem really, I think, like so many things, relates to the name. Microservices is an appallingly badly chosen name, and I think even James and Martin will admit to that these days. When people use the word micro, a whole set of people went off on a journey that said what they mean is really small. So Fred George is also the man behind a version of extreme programming that is like, extreme programming is not extreme enough for me. I'm going to go really extreme. I'm going to fire all of the product managers and the testers and just have devs talking to customers and that. So his thing is, I'm going to take it to the next level. So he was like, let's have basically 100 lines of code services, right? If it's more than for one programmer to develop and design, maintain, it's not a microservices, right? And you can find blog posts on site. Single function microservices price with the highest degree of granularity. This increasing granularity gives us more control over resource consumption, availability, and scalability. So people were really focused on making these things as tiny as possible, right? Arguably, their mistake is that really the micro just means that notion of independently replaceable and upgradable. Obviously, if something gets too big, you can't do that, right? So this leads to what we tend to call the nano services anti-pan. So this, I can't remember whose diagram this is, but these float around. These are called basically Death Star diagrams. And Death Star diagrams represent all of the connections between the various services that you have. Obviously, you get this problem of, if I've got 2 things, I get 1 connection. And if I've got 3 things, I get 3. But when I get to 5, it's about to 25. And it keeps going up exponentially, right? So the more things you have, the more connections you have, and you end up in this web. I don't think this is Monzo's, but Monzo famously put their Death Star diagram online. So this is the complexity we cope with at Monzo. And they became the main character of the day, with the rest of us kind of going, why? So what are the problems? So one problem is effectively that you have so many integration points, right? You've massively increased the complexity. Your reasoning about anything that you do is now really hard because you're connected to a huge number of things. Your latency increases significantly, right? The problem that some of these people identified with their microservice environments were like, it takes 34 calls to render some piece of output to the user because they were having to literally bounce from task to task to task to task in this function as a service model in order to get anything done. So of course, every single call, even if it adds a small amount of latency, that all mounts up. So they were resulting in incredibly high latency calls. They have a high operational overhead. If every single one of these things needs build and deploy scripts, telemetry, you're just creating a massive overhead for every single service. Every piece of metadata that you need to maintain is now increasing by the number of items that you're adding. Typically, when we see these, people are working in a very synchronous fashion. They've gone into their code base and said pretty much, hey, every function call in here should be a separate microservice. Or maybe at best, hey, every class in here should be a separate microservice, right? And they're making RPC-style calls between them, but those are heavily coupled, both temporally. Both things need to be available at the same time for a synchronous conversation, basically, to succeed. And also just in terms of behaviorally, changing anything's really hard because there's a web of connections that I have to basically work my way through. We end up with very low cohesion and perversely high coupling, where people will think my microservices will give me loosely coupled services. And in fact, they've just got highly coupled functions talking to each other. Long release cycles. Weirdly, my release cycles end up increasing because none of these things are actually independently deployable. They don't really even meet the module definition. So in order to deploy anything, I have to figure out, hey, what things do I need to actually deploy all at the same time in order to make this work, right? And they're a significant obstacle to reasoning because you want to know how something is done. Well, it's done across 34 services. And that's also a problem in planning. What teams do I need to get involved? What people do I need to get involved in the process, right? So this whole thing becomes a house of cards. So micro is a bit of a problem word. Services, unfortunately, also became a bit of a problem word. So what tended to happen was people were fixated they misinterpreted slightly what that service process boundary means. And they said, well, a microservice is a process. Each service is autonomous and self-contained and runs as a unique process. And if it's a process, well, hell, that means in our modern world it's a container, right? So each microservice is packaged as a Docker container to enable deployment to Kubernetes cluster application orchestration. Great. A cloud-native application consists of discrete reusable components known as microservices that are packaged in containers. And this thing spread throughout DevOps like wildfire, right? Containers are microservices. These two terms, as far as they're concerned, are synonymous, right? Kubernetes, what runs in my pod? My microservices, right? They're two quite different models. Lambda's doesn't really get functions as a service, don't really get to escape that model. Functions launched by AWS Lambda is all that you need to build a microservice to the level of granularity desired, right? So all this kind of surfaced a little bit with the Prime video. You can't actually find, there's an archive link on this. The slides get on my GitHub, but there's an archive link because they've taken it down now. But what happened was Prime Video, they're here in London somewhere, so hopefully no one from Prime Video is in the talk. I'm not going to find them anyway. They had effectively an architecture which consisted of a number of Lambda functions which are being orchestrated by a step function. And they decided, that's a bit of unnecessary distribution and complexity. We're just going to basically rewrite that as a single service that's hosted in EKS. And actually the whole thing, or ECS rather, the whole thing is much more efficient now, right? So they just reduced the cost of their process model. Unfortunately, the way they highlighted this thing was essentially from distributed services to a monolithic application. And the internet exploded. Microservices are a disaster. Amazon has abandoned microservices. I mean, it's like the idea that you woke up yesterday and there's Amazon now running a huge monolith, packaging its entire e-commerce operation. Apparently, according to the internet, that was the case. But really, it was just the one service that changed its process model. But the usual suspects decided that they needed to have their say, right? Rent-a-gob appeared and said, it's clear in practice, microservices pose perhaps the biggest siren song for needlessly complicating your system. Okay. I also think there are dangers that lead to this kind of model of application development. So Team Topologies is a great book. If you've not read Team Topologies, you may well find that your managers are all reading Team Topologies and going, we must work according to the Team Topologies model. It's kind of become the latest, thing that your managers are all doing. But it doesn't really include anti-patterns, which I find a bit strange. So one of the things they talk about is fracture planes. So fracture planes basically are what we used to talk about as being partitioning your system. How do I partition it into pieces? And they've got models of various fracture planes, but they don't talk about anti-patterns of that. And what I commonly see is this fracture plane of team availability, which kind of said, we've got this thing we need to build. Okay, where should it live? Oh, in that team with their microservices. They're really busy. Let's just create a new microservice. So people just create whole new services to create whole individual HTTP endpoints that basically say, well, our API is just going to consist of an entirely new microservice over here. How will they communicate? Well, we'll send messages between them, right? It's just a lot of needless complexity. And what they're doing is they're trying to leverage microservices to avoid an organizational problem of bottlenecks that they might be better solving with something like inner source by effectively saying, we just create whole new components the whole time. And effectively, it starts well, and then you end up with 500 components, and you wonder what happened. And each one of them was an individual new function that you added. And part of the problem is, I won't read that quote to you, this. All right. So this is back in 1975. It's kind of, we knew what we were talking about then. So it's a comparison basically of the cost on basically the y-axis to the number of components. And the idea is that the intramodule effects, that's the complexity inside your code base in a given module. As you increase the number of components, that goes down. So your cost of any individual component lowers because it's doing less, right? But everyone forgets there are also intermodule effects, which is essentially the complexity of modules talking to each other. And as I increase the number of components, that goes up. And that leads to this curve, where effectively there is a point at which I cross over from cost going down to cost climbing back up again. I've now got too many components. And some of this is down to a failure in that terms of fracture plane availability to realize the following problem. Right. Cost of ownership is an order of magnitude greater than cost to author, right? It doesn't, you can do a simple thought experiment. If it takes you 3 months to write some software, but 36 months to own it, then it's an order of magnitude greater to own that software, right? We can do simple calculations. You estimate basically, say, that a team costs you about $1 million a year, and it takes them 6 months to write a piece of software. That costs you $500,000. If the software lives for 5 years, right, that's $5 million. Let's say that 50% of their time is spent in BAU, right, which is optimistically the cost of the software, if not all the $5 million. That's $2.5 million compared to 500,000, right? We don't need to get better at authoring software. Our challenge, the financial challenge to any business, is not I need to write more code faster. It's I need to reduce the cost of owning my software. Fundamentally, that's the ChatGPT problem, right? No one ever said, our business will succeed if only we could write code faster. The actual thing is, our business will succeed if only we could reduce the cost of owning software. So the problem is that effectively that fracture by availability, it will essentially pivot, start increasing our costs and bankrupt us because we haven't taken control of the cost of ownership. Okay. So some pragmatic advice. How do you get out of this scenario? I note basically, the note here is, they did a huge study in 1966, a guy called Jack Brame, a lovely guy. He basically said, every piece of evidence we have says that no one takes any advice you offer them. So I give the rest of this talk in the sure and certain knowledge that you'll ignore me, but there we go. Right. So the 4+1 model was created by Philip Crutch, and it's a way to think about architecture. And one of the problems in architecture is that we apply a lot of different models to reason about how we're going to build software. And not all those models fit conceptually into the same space. And we get into problems when what we're actually doing is trying to combine too many things in one space. So scenarios effectively are the requirements. Logical is the domain that we're actually trying to look at. Development is how we want to basically build a solution to that in terms of how we slice up our software. Process is physically how many processes are we going to use, how will they interoperate, and physical is how will we deploy that on disk. We'll run through that again. So I'm not going to dwell on scenarios. Scenarios are about how you capture your requirements, use cases, scratching user stories, scratching things on the back of cigarette packets, whatever basically appeals to you. At the minute, I'm a big fan of domain storytelling. I think it's a very modern way of doing use cases. Essentially, you have an actor, which could be a computer or a person doing something. That's an activity which they do, and they do it on a thing, right? And you can effectively build descriptions of whole systems using that. You also want to think about non-functional requirements. Again, I'm not going to go into it in depth. I'm a big fan of attribute-driven design or ATAM as a way of effectively capturing quality attributes for our eventual software. All right, the logical model. So the logical model is supports the functional requirements, what the system should provide in terms of services to its users. The system is decomposed into a set of key abstractions from the problem domain. So this is where we're thinking about what is the problem we're actually modeling? What is the business problem? What does it look like, right? So it's kind of our domain model. And the key thing we want to, in terms of this talk, right, get out of the domain model, is effectively what are our subdomains? Okay. And you can effectively, how do you think about what the subdomains are, the parts that you can break this up to? So natural seems understood by SMEs. So I work at Just Eat Takeaway, right? And an obvious high-level kind of approach for us would be to say we have customers, we have partners, people in restaurants and pharmacies and the like. We have couriers, people that deliver food for you, right? So there are those, at least those three pieces. We might also think there's something payments that moves money around, or something fulfillment that moves work around. I've got 5 pieces, and I can keep going like that, right? I can keep talking to the business about what does this business look like. Domain storytelling, which we just saw in the use case stuff, you can actually look at that model, which effectively is modeling out use cases in your domain and draw up some boundaries. Or value stream mapping, which is effectively done in Six Sigma or the like, essentially says, hey, we can break up any given workflow into about 5 to 15 separate processes. All of those are valuable techniques. I don't want to pick one, but at the end of it, what you want to do is come up with your subdomains. Quick idea. So this is, don't worry about it, you can see about seeing the detail. This is what a domain storytelling diagram looks like for ticket sales. And the idea effectively is that you can say, okay, maybe subdomains are where an actor doesn't interact with any other actors, just produces an object. Where there's one-way information flow, so in other words, it's all going to a given actor. Different triggers, so hey, maybe we need to break things up because this one is triggered by an event in time, this one is triggered by user action. Maybe there are things that happen off stage, like payments. Maybe there are different languages. In other words, the DDD concept of we talk about policy this way, you talk about policy that way because we're underwriting and claims. different use of the same thing, right? Whatever your heuristics are, that's not important to this talk. I can kind of slice this up and say, I think those are separate subdomains in my system. And I can reason and talk about those subdomains as separate ideas, and they may have separate reasons to change. Domain storytelling is great. I encourage you to go and look at it. Be aware, and which is a point we will return to, obviously our business is not static, right? There's this old joke, and it's a bit pre-pandemic as a joke, but how do you know you live in the kind of noughties? You've sat in the same desk for 5 years and worked for 6 companies, all right? So business models change, businesses pivot, we add new ideas, Just Eat Takeaway doesn't just do food anymore, right? And as those things develop, obviously there will be changes to your domain model, right? Tasks and activities change more frequently than processes. And what we mean by that is, this thing called the guest life cycle when you check into a hotel, right? Where it goes from browsing to check-in to staying to completing your stay. It's called the guest life cycle. It's well understood in that industry. And it's divided into processes, and a typical process is check-in, right? Within check-in, over time, that has changed. Once upon a time, I got a physical key. Now I get a card, right? So processes like check-in tend to be very long-lived and very stable. Tasks and activities, like I hand you a mechanism to get into your room. Now I've got Hilton, for example, which I can just do it on my phone app, right? Change over time quite rapidly. So it's best to model processes, not activities and tasks. And one of the reasons you get into trouble with effectively functions as a service model is you're modeling activities and tasks. So logical reviews require constant gardening, and we continually have to converse with the business to change our logical model. So development. The software is packaged in small chunks, programs, libraries, or subsystems that can be developed by one or more small developers. So we take those domains, that model of our broken down domains, and we say, how are we going to build that? Okay. And that's where we're going to define our service boundaries. Now remember, the parts of the original problem must be solvable separately. So that's this process, activities, and tasks thing. It's often better to focus on processes because they tend to orchestrate stuff, right, as your subdivision, not to focus on activities and tasks within it because they may just be sharing state, etc., as part of the flow. All right. I refer to this as the Goldilocks point. That's what we're looking for, right? This point in decomposition where effectively we've reduced the complexity of the size of the individual component without trading that off badly against the number of components that we own. It is hard to find, right? That's why we often say you'll do your microservices twice, right? There are certain helpers. So there are what Neil Ford and friends in software architecture, the hard parts, talk about granularity integrators and disintegrators. So disintegrators are code's too big, won't fit in my head. Distribution of code changes. In other words, effectively, there are lots of changes in this area and lots of changes in this area, and they're driven by quite separate forces. Continuous change for new problems. So in other words, whole loads of people keep wanting to change this source code. Could we, and it's a constant point of conflict, could we break it up? Integrators, ACID transactions. Don't try and split ACID transactions across independent processes. It is painful. Shared code. In other words, essentially, these two things both need to use the algorithm X, right? We don't really want to share the code. Probably they're both just the same thing if they're both using algorithm X. Shared data, right? We have to keep passing this data structure between all these little tiny components, and it's a big, heavy data structure. Maybe actually, if they're all operating on the same data structure, they're all the same thing. So fracture plane, in topology's terms, is looking for a business domain bounded context, actually, which is a hell of a phrase, which is kind of like hedging your bets between, I don't know what a domain is, I don't know what a bounded context is. So bounded contexts from domain-driven design explicitly set boundaries in terms of team organization, usage within specific parts of application, physical manifestations, blah, blah, blah. So what it basically means is a bounded context is effectively an artifact of this phase, and it's the people, the process, and the technology that you use to implement a subdomain. And within that, you agree, for sanity, we will agree that the words have a given meaning within that team, and et cetera. Effectively, when we say claims, we mean this. Typically, when you begin, you try and align them with domains. Over time, because domains change, they will drift out of alignment with domains. That's what context mapping is all about. All right. But they're not quite the same thing. People use them interchangeably. Uncertain, so what should you do, right, in terms of breaking things up? So if you are uncertain about your domain, about basically how you might split it up, if you're sitting there going, I just don't know, is it this, is it that, etc. I can't figure out what my band of contexts are, or effectively if you're just below 30 people, a good starting place is a monolith because it will help you learn, okay? You might use modules within it, and those modules may be your first stab or attempt at saying what I think the subdomains are inside my given monolith, and it's an easy place to refine them because they're easier to change there. So typically you're going to have a single CI boundary. You don't want more than about 5 pizza teams basically working on this. 5 teams, 10 pizza rule, okay. And it needs a mono repo, right? It needs a single repo where all of the code lives because it's a single CI boundary, all right? So it's a good first step. If you're uncertain, start here. All right, move on that. If you clearly can see that you have clear domains, and those domains have complexity that will fit in your head, right? Then you've got an easy model which basically says, great, I can effectively say I'm going to have a microservice for each one of these domains. So you've got some constraints, forces for change are cohesive, any ACID requirements can be satisfied within the service boundary, and that's your ideal microservice. And that's the poster child we were all really shooting for back 10 or 11 years ago, right? Clear alignment, I have a domain, code for the domain, subdomain, code for that subdomain fits in my head. There are no ACID transaction problems. All the changes land up here rather than across everywhere else. There's my microservices. If you can find those, you're good. All right? And that is what microservices were intended to really model. But there are some more complex models. I can't really, I feel that this is one subdomain, but the code is more complicated than I can fit in my head. So I'm facing this challenge of seemingly unnaturally splitting up my subdomain because of the complexity of the code base. So one option is, can you find a seams inside the subdomain? Is this subdomain generally irreducible? So you can look for activities they're more likely to change, but you could say, oh, check-in actually has 2 main activities, verify customer, give customer access to room. That's probably not going to change. I'm going to split that into 2 parts. I've now got 2 manageable subdomains whose complexity I can understand, right? Beware of the complexity of intermodule dependencies if you do that, right? And that is about, I may have to push a chunk of data between them, which refers to effectively the customer. If it's independently solvable, each split within a subdomain becomes a microservice. But what happens if I can't do that? What happens if I look at it and I say, there are ACID transactions between the 2 halves? There's a huge amount of data that I'm moving. So we have these around, for example, baskets. When you're shopping and you want to price effectively a basket as a result of adding an item is effectively a transaction because you want to see a coherent set of delivery charges or whatever for adding that item. So it's an ACID transaction that needs to run even though there's quite a lot of complexity around pricing. Okay. So what do? You need what's called a macroservice. All right. So macroservices effectively are using modularity to try and effectively break up our microservice into a number of pieces. So the idea comes from Cindy Streeterhan, and basically it says it's effectively a service, right? But you can effectively componentize it inside. It likely has more than one module, library or service inside, so it consists of more than one part. Those parts effectively are usually independently replaceable, but it may be sharing data, maybe a CI boundary, most likely, right? Typically, it has a larger team, 20 devs, 3 teams working on it. So effectively, that's a manageable number. We can effectively all sit in a largest room. We can chat to each other. So it's a manageable level of complexity. It may or may not need a mono repo. In other words, probably we want to get everybody's code in the single repo because we're likely to want to have some kind of CI boundary to make sure that everything works together because we may well be forced into releasing our software together, right? Dependency management becomes a lot easier, though still non-trivial. The fewer the service repos, the better observability and debugging, right? So this is this model effectively of a macro service. And it's kind of, if you like, the missing piece in our armory, because it lets us say, you know what? This thing doesn't really devolve into a simple microservice. It needs to be a bit bigger. We quite often look at these in terms of microkernel architectures. So an interesting way to build these is to effectively have some kind of centralized thing that you need to do, some kind of workflows, for example, pricing. Effectively have modules that represent the things that pricing needs to do that effectively can be owned by individual teams, allowing you to essentially separate the cognitive load to individual teams and one core team. You all have to work together, you can all share data, but you can break the problem up in a more useful fashion that makes it more manageable. Okay. You may have a very simple model where essentially you think each one of these domains is trivial, these subdomains, right? And if I was to put them all out on their own, I might rapidly hit that nanoservices problem because I'm increasing the number of items that I've got. These are services where you feel this thing wouldn't earn its weight and cost in terms of telemetry, observability, managing build scripts, etc. So the question is, can you combine them? And typically, we do this all the time, we just don't know it. So if a team owns a lot of small services, you're effectively doing this. You're giving them basically, because teams are a bounded context, even though you don't really know that, you imagine they own multiple bounded contexts, but you're effectively giving the teams a whole load of software and saying, hey, you own all of this. So if you can find ones that are kind of aligned, you can combine it into a macro service. You simply say, okay, this service actually has a number of moving parts for whatever reason, but effectively it's combining all these smaller domains together, right? So the code for domains is much smaller than your head. You can question if it should be a module, right? Maybe this thing could just be a module inside this larger domain rather than effectively being a standalone service. So I've still got replaceability, probably a component, but effectively I want to move it into that kind of model. So the question you're really asking is it truly independent of others? Does it have separate reasons to change? Are the behaviors it operates about the same work item? Are we talking to ourselves? Typically, you may find, and often find these by experience, by looking at your microservice estate, and you find two components that are very chatty, they're talking to each other, and they're basically exchanging information about the same thing. They're having a conversation with nobody else but each other, they're tiny, and the data going back and forth is the same thing they're just operating on. Typically, you can just combine them and make them two modules in one service with some shared data, right? Just because you've chosen to use microservices doesn't mean you can't have a microservice that uses modularity. Make sense? Watch for basically another good smell is you've got an ACID transaction that's distributed over them and you're having to do tons of work with sagas to effectively figure out how to orchestrate everything. That's typically often a smell that you've got these small pieces that generally want to live together. Okay. The thing that we do note though, right, is if the logical domain can change, and if we base our partitions on the subdomains, if the subdomains change, then essentially our microservice boundaries may well change, or what we choose to do. And this is one of the problems with microservices we identified right at the beginning is when your components are services and remote communications, then refactoring is much harder than with in-process libraries. So one of the costs of microservices we forget is that change is harder. So if your business is always changing in certain areas, then maybe a good reason to make that area a macro service, because effectively those changes with inside will be much easier than those changes that move across. All right. I'm going to skip that. Barry's going to talk somewhere else, and I'll skip that one as well. All right. Okay, so processes. So how many physical processes does my microservice have? Remember we said basically it's probably not one. Okay. So when we talk about the process model, it's a group of tasks that form an executable unit. They represent a level at which the process architecture can be tactically controlled, start to recover, reconfigure, and shut down. So the process step is when we figure out how many processes do we want, and if we have more than one, how do they interoperate? Are they talking over to each other by Kafka or gRPC, or what's going on? And the trick here is that effectively we want to think about models that help us expose basically a decent model of how processes work. So 12-factor apps is a good model. We want to, in a modern world, seek to be application-centric, not infrastructure-centric. In other words, what we don't want to do is have tons of knowledge in our code about the infrastructure. We want to essentially choose to host our code in infrastructure. So 12-factor apps is a good model. The other things to think about when you talk about interoperability is async versus sync communication, messaging or REST, RPC or eventing, that kind of thing. We're not going to cover that so much here. Right. So even back in the original paper, there was this clear idea that a service may consist of multiple processes that will always be deployed and developed together. Now, the 12-factor app model is really useful here, and it basically says your application may consist of a number of processes. Those processes are things that have different scaling characteristics. So if I have an HTTP worker that's listening to HTTP requests, and a Kafka worker that is listening to a partition on a Kafka stream, they will scale very differently. The Kafka worker listening to a stream is only ever going to scale up to the number of partitions that I've created on my stream. The HTTP worker is going to scale up as far as it can in order to handle HTTP requests coming into the server. If I combine them together in one process, which do I scale them for? Right, you get the classic Kubernetes problem of people are scaling for CPU because effectively they're scaling what would be an HTTP worker, whereas in fact I'm okay if the service worker runs hot. What I care about is actually the latency on the queue, on the queue or the stream. So because they have totally different scaling characteristics, they should be totally different processes. And what we tend to think of these as process types. What are the different process types that my service has? What are the different ways it may need to scale? And that collection of them is called the process formation. And without that, you're just going to think, oh, you know, microservice equals basically Docker container, right? And that isn't the reality. The reality is microservices may consist of as many processes as I need to scale effectively in terms of process types, and as many instances of that as I need to meet my scaling, right? There are some simple cases where it's just an HTTP worker, but in other cases, you're going to need to want to scale things very differently. Okay. Some integrators and disintegrators, some processes, basically scalability and throughput, but disintegrate into smaller pieces for different scalability requirements. Fault tolerance, right? I actually need to break this thing up because I don't want faults here to affect the other thing. And integrators, I need to do an ACID transaction. I can't make it across two processes. I have some shared code I don't want to move across two processes. All right, and finally we get to this model, which basically says a microservice is an application, right? A whole microservice is an application in the 12-factor app sense, which may be basically a macroservice may consist of multiple apps, or maybe a microkernel model with multiple plugins, right? And an app or a microkernel plugin has effectively a process formation of multiple process types. And that's what you need to think about at this level. Physical. So the physical thing, various elements, networks, etc., is effectively where you decide to put those processes on hosts. So this is where you decide that thing runs in Kubernetes, or it runs in ECS, or it runs in Serverless and Lambda, or I'm going to run it on EC2 instances, or whatever your hosting model is. It's going to run on bare tin in my data center, right? The physical one, perhaps least interesting for our conversation, essentially says, now how do I think about that? And the problem we've kind of got ourselves into a lot in thinking about microservices is we've got very confused about which one of those 4+1 things we're talking about, right? Typically, a lot of what we think about in terms of microservices happens in that development view. How do we allocate people, process, and technology to a particular partition of our problem space? It's very separate from how do we actually partition our problem space. It's very separate from how many processes do we actually need to effectively operate that software. And it's very different from how do we deploy those processes at runtime to our infrastructure. And it's nothing to do with size. Micro really just means code that fits in your head and a replaceable unit of software. And service just really means something that uses a process boundary rather than an intermodule boundary for separation. And that's where we've gone wrong, right? But ultimately, feel free to start with a monolith, use microservices, and be aware of macroservices. They're the kind of missing piece of the puzzle. All right, thanks very much.